For the first molecule, I'm going to start by drawing in a couple of my hydrogens. So there's one here. There's no hydrogens here. There's 3 hydrogens here. This is a CH3 group, and each of these has 2 hydrogens. Now I'm just going to draw my lone pairs. There's 2 sets of lone pairs on the oxygen, and there is a lone pair on the nitrogen. We know that because both of these are neutral atoms, and in order to be neutral atoms, those are the number of lone pairs they have to have. So I'm going to start by taking this lone pair and pushing it over towards the pi bond. This carbon here has 4 bonds, so I'm going to have to break a pi bond at the same time to not break octet, and that's going to give me this alternate resonance structure. We've now got a double bond here and a lone pair on this carbon here. Now we have a negative charge on the carbon and a positive charge over here on the nitrogen. I'm going to take the negative charge and push the electrons away from it. And this carbon already has 4 bonds, so at the same time I'm going to need to break this pi bond up to the oxygen. You'll note that because we started with a neutral molecule, any resonance structure that I draw is going to have to be net neutral. So it'll have a positive and a negative charge in the case of these ones that I'm drawing. So there are 3 of our major resonance structures for this molecule. For the second one, we could have this ketone here simply with the pi bond going up into a lone pair, and that would give us a negative charge on our oxygen and a positive charge on the carbon below. Now to stabilize that positive charge, I can move this pi bond towards it, and that would in turn put the positive charge down on this lower carbon, which is the one we took electrons away from. And those are the 3 major contributing resonance structures here. Finally, for the one on the bottom, this nitrogen has a lone pair yet, and we could push these electrons over here, and then to not break octet on this carbon, since it already has a hydrogen, we'd have to break the pi bond and put it on the carbon there. That would give us this molecule here with a negative charge on this carbon and a positive charge on this nitrogen. We can take the negative charge and push electrons away from it, and at the same time we're going to have to break this pi bond so that the carbon here doesn't have more than a full octet since it has a hydrogen attached, and that will give us the following molecule. And our negative charge is now up here. If we complete this, we'd simply take this negative charge and put it here. And then nitrogen would have 5 bonds, so I'm going to have to take these electrons and put them on that carbon. So now I have the following molecule, which has a negative charge here and a positive on nitrogen. Now I can take this lone pair and push it down, and take these electrons and push them down here, and that is going to put the negative charge on the bottom right carbon, and I can take this lone pair and push it over and take these electrons and give them back to the nitrogen, and that takes us back to our starting molecule here. So here are the 5 major resonance structures for this molecule.